Hello. So today we'll be doing course schedule 4. It's today's daily question 1462. So there are total of num courses which we have to take, and there's a prerequisite array like one course is dependent on another. Okay, it can also be indirect. If A is prerequisite of B, B is C, then A is a prerequisite of C. Okay. We are given some queries, and for every query UV, we have to check if U is the prerequisite of course V or not, and we have to return an answer array for every each of those queries. Okay, looks simple enough. Actually, if I look at the constraints, I can honestly, I can create my graph, right? And for Q and queries, I can honestly just process each query like this and it should work because there are 10 to the power 4 queries. DFS is gonna take n square time because um, it's E plus V, right? E plus V, and the edges are V square. So DFS should be taking around V square, and the queries is like 10 to the power 4. This is also around 10 to the power 4. So it should, if you just brute force this, it should work. That is what I'm trying to say. But let's try to optimize this. When our number of courses is less, and let's say the queries were of order 10 to the power 6, then this approach will fail, obviously. So what we can do is we can pre-compute our prerequisites for every pair of nodes because it's only 100. So for every node, if we are going to pre-compute the uh, prerequisites, DFS is 10 square, BFS is 10, sorry, V square, and for every vertex that is going to be around V square. So it should give it something like a V cube. So that should be around 10 to the power 6. And after that, for every query, we just answer it in O1. So our overall complexity will be V cube plus number of queries, right? So that is what I have in my head. I'm just gonna pre-compute this. So first of all, I'll create my graph, right? I'll insert the edges, uh, num courses, what size, I++, and okay, int u is prerequisites I0, and my v is this. So I can just insert g u dot pushback v. Okay. Now I'll make a 2D array for storing my prerequisites. It's basically, it will tell me if A is a prerequisite of B. It's a Boolean array basically, right? The size I'll initialize to num of courses, and the second vector will again be sized similarly, and I'll initialize it with false. I do need a DFS helper method, right? It should take in my graph, right? It should take a index. It will have a source. Source is basically the first index I pass it to. Then I will need this, right? So I can update it. Awesome. So how DFS should work is, when I visit a node, I'll try to explore its neighbors. Gidx dot size And IDXI. This is what I'm going to go to. This is my destination node, right? Now I'll check if that prerequisite is already set or not, right? If is prerequisite of IDX, sorry, source and destination. This is already set. Then I can, if it's not already set, I'll set it as true, right? And after that, I'll enqueue another DFS. Here it will be destination, it will be source, and I'm gonna pass the prerequisites array. So that is going to be my DFS for every adjacent node. I'm just gonna set this to true. So basically, every of my source is gonna cover every of my all possible destinations that it can go to, right? So now I'm gonna do I smaller than num of courses I plus plus, and for every index I'm going to enqueue this DFS, right? I and is prerequisite. Now this will pre-compute my prerequisite 2D vector. Now I can initialize my answer to queries dot size, right? And for every query, what I'm going to do is, again, U is going to be queries I0, I1, and I can set answer I to be the prerequisite, right? Whatever that value will be. So something like this should work. And it should be fast as well. Let me try and run that. Oh, sorry. Num of course is of course just an integer. Uh, where is that error coming? Okay, let me try checking that. That size is correct. Num courses prerequisite I01 UV U dot pushback B. That also looks correct. This also looks correct. This TFS loop is looking also right. Source destination I plus plus. This is by reference. Non-zero offset 24 to null pointer. Okay. Am I reaching this guy? Not. So, am I reaching here? Actually, I didn't initialize my graph. That's why num courses. Right. This should hopefully work. Should be prerequisite size. Yeah, okay. Now that's working. Let's try submitting that. Okay, awesome. Uh, so yeah, I think you can also do this with Floyd Warshall. Floyd Warshall does the same thing. It has this recurrence relation. GI J is, you basically maximize this, right? KJ. So it uh tries to go through all the subpaths, all the intermittent nodes, something like that. Obviously, there's going to be something like this. This is for distance calculation, but I think it can be modified to just return that Boolean relation whether U is the prerequisite of V or not. So yeah, pretty good question.